Lewis dot structures?
Yes, sir. Let's see.
Can you draw Lewis dot structures?
No, sir, no, I didn't watch that part. Lewis.
Sorry?
No, Lewis dot.
Okay.
Yes, yes, sir, I know.
You have watched the lecture, right? So I can give you some questions where you can draw the Lewis dot structure, correct?
Yes.
Okay. Assalamu alaikum, madam. How are you?
हेलो सर, अस्सलाम वालेकुम। या आई एम गुड।
आपने लास्ट लेक्चर देखा था?
हाँ सर, देखा था।
You understood Lewis dot structure?
या आई ट्राई।
हाँ. Okay, so who will tell me what are the steps for Lewis dot structure? What's the first thing that we do? Iram and Abdullah, you tell me, guys. What's the first step for Lewis dot structure?
Determining the valence electron, total valence
Total valence
electron.
electron. Yeah. So the total valence electron will be how much? How many valence electron are there in hydrogen, Iram? You don't remember, Iram? याद नहीं है आपको?
So it is 8.
नहीं है, याद नहीं, याद कीजिए. हाइड्रोजन में 2 इलेक्ट्रॉन से ज्यादा होता नहीं है, right? So the valence electron will be how much? What is the electronic configuration for hydrogen? Iram, sorry, it cannot have more than 2 electrons in its last shell. और ऐसे सिर्फ एक ही होता है हाइड्रोजन में, 1s1. So 1 valence electron in hydrogen, and there are 2 hydrogens, so multiplied by 2 plus how many in oxygen? How many valence electron in oxygen?
6.
Yeah. So this will give you a total of how many valence electrons? 8 electrons. What is the next step? What is the next step?
Skeleton diagram.
Yeah, drawing the skeleton. Now in skeleton, the most important thing is the choice of central atom. The first choice is the choice of central atom. So which is going to be the central atom, hydrogen or oxygen?
Oxygen.
Yeah, correct. So we are going to make something like this. And then we have to check whether all of these atoms are happy or not. So are the hydrogens happy? And how many electrons we have used? Since we have made 2 bonds, then we have used, so this is the total valence electron, that is equal to 8. In the skeleton, we have used how many? We have used the 4 electrons, so remaining are 4. So we have to fill more 4 electrons. Tell me, are the hydrogens happy? That means is the valence shell of hydrogen filled? Or does it need some electron?
It is filled.
It is filled, right? It cannot hold more than 2 electrons, and this is the only case for hydrogen, it cannot fill. Now what about oxygen? Is oxygen happy? How many electrons should be there for oxygen to be happy?
4 more.
4 more, right? So it has 2, and we'll get 2 more electrons like this and 2 more electrons like this. So from here we can say that the bond pair is equal to 2, and the number of lone pair is equal to 2 in water. Okay, this is an important conclusion that you should always remember it. Okay, next moving into BeF2. So beryllium fluoride. So total valence electron is equal to how much? And this is the reason that why I have taught you guys periodic properties. I have taught you guys how to get the valence electron, how to get the, like, you should know where this beryllium is. You should know what is the atomic number of beryllium also. If not, then you should know at least where it is. That is why I have taught you the complete periodic table. What's the atomic number of beryllium? Beryllium's atomic number is 4. What will be its valence electron? Think about the electronic configuration. Yeah, correct. So 1s2 and 2s2. So it has 2 valence electron. What about fluorine? How many valence electron in fluorine?
7.
Yeah. Now I will multiply 2 because there are 2 fluorines. 7. This will give me how many electrons?
16.
Very good. Now the next thing is skeleton, which is going to be the central atom.
Beryllium.
because fluorine can never be the central atom, and we'll write the fluorines like this. Again, same things we are going to do. The Q is 16. We have used how many? We have used 4 bonds to make. Sorry, we have used 2. We have used 4 electrons to make 2 bonds, and the remaining is going to be 12 electrons. Now tell me, guys, is the fluorine happy? Is the fluorine happy? What happened?
Yes.
Tell me. Fluorine is happy. How many electrons are there in
Yeah.
fluorine right now in the skeleton? How many electrons does the fluorine have?
2.
2, right? But 2 is not happy. For happy, it should have how many electrons?
8.
8, right? So we need to fill the electrons like this. So I will fill 1, 2, 3, 4, 5, and 6. Now it is happy. Look into the next fluorine atom. 1, 2, 3, 4, 5, and 6. Now it is happy. All of you got this? Yes or no? Please tell me.
Yes, sir.
Yeah? Okay. Fine. Now, since we have completed the electrons, even though beryllium is not happy, we cannot do anything about it. Also, fluorine cannot make more than one. Fluorine cannot make more than 1 bond. That is why we are not giving it any double bonds here. Okay. Write this down. Right next for SiCl3. Send me the structure of SiCl3, guys. Write everything you have. Total valence electron, the skeleton. I think SiCl3 नहीं होगा. Wait a second. SiCl4 का बनाइएगा please. SiCl4, not SiCl3. Also draw for ozone, that is O3. And I think he did not NO3 negative. Send me if you're done with SiCl4, and then after that move on to O3. Okay. Please send me when you are done with SiCl4. Yeah, Iram, that is correct. Silicon and chlorine, everyone is happy here. You can right now then do for oxygen, the O3, ozone. Iram, you have to also put it in a bracket, like square brackets, and show the negative charge. I think you will remember the last class, we did it the same way if you have watched the lectures. Right? You
Yeah,
have to
yeah, I
put the
forgot.
NO3, I know, you have to put the NO3 in square brackets and again give the negative charge outside that square brackets. Okay, Abdullah, looking at your answer. खुद से बनाया है आपने अब्दुल्ला? जी, yes, Abdullah, tell me.
Yes, sir.
Where is the skeleton? Skeleton तो है ही नहीं. उसके बाद आपने बनाया? Yes, sir. Okay, but I hope you can type in one line. Okay, fine, fine, fine. Iram, did you make for ozone O3?
Yes, I'm doing it. Just a second.
अच्छा. Yeah, yes, Iram, that's fine, correct. Okay. So we can move on to the next topic, that is formal charges. Okay. So please write the next topic. Formal charges. Okay. So for different levels dot structures, you have to get the formal charges. Okay. So the formula for formal charges equal to the total valence electron minus the total number of non-bonding electrons. Please see what we have writing here. Total number of non-bonding electron. Non-bonding electrons, not the pairs. Okay. So this is total number of non-bonding electrons. Okay. Then you have to subtract this by the half of total number of bonding electrons. Total number of bonding electrons. Essentially, what we are seeing here is, see, either you can add an electron or you can remove an electron. If you're adding an electron, it will be going towards the non-bonding. And if you're removing an electron, That means it will be showed in the total valence electron if electron has been removed. Okay. Now that means positive or negative charge. Total number of non-bonding electrons, we are taking the total number because non-bonding electrons is attached to only one atom. But the bonding electrons, if you see here, the total number of bonding electrons, then you have one bond. In this bond, we have two electrons, but only one of them is belonging to this A atom and the other one is belonging to B atom. That is why we have done it half. So we can further write this as total valence electron minus the total number of non-bonding electrons minus the total number of bonds. Okay, minus the total number of bonds. That is your formal charge. For example, I will take the example of O3 molecule, ozone. So here you know that we should have drawn the O3 molecule like this: oxygen, double bond oxygen, single bond oxygen, and here we are having 3 lone pair electrons. Okay, and then this oxygen is having 2 lone pair electrons, right? And this oxygen is having 1 lone pair electron. Is that right? Yes or no? Please tell me. You got something like this, all of you? For O3 molecule, you have got this Lewis dot structure. Yes or no? Please tell me, guys.
Yes, sir.
Yeah. Okay. Now here we have 3 oxygen atoms: 1, 2, and 3. I will calculate the formal charge at all of them. So for the first one, what we have to do, formal charge is equal to total valence electron. What is the total valence electron on this oxygen atom? Please tell me. Electron minus lone pairs minus bonds. Total valence electron on oxygen is equal to how much? Please tell me, guys. यहाँ पे नहीं, in general oxygen पे कितना इलेक्ट्रॉन होता है? How many electrons are there in oxygen? Valence electron?
6.
Okay, very good. 6. How many non-bonded electrons does this have? This first one. How many lone pair electrons are there? How many electrons are there which are not bonded?
6.
Sorry, can you repeat that again? How much? I could not hear that actually.
4.
4, right? So this has 1, 2, 3, and 4. And how many bonds are there? How many bonds?
2.
2 bonds, right? The formal charge at the first oxygen is equal to how much? It is equal to 0.
So,
हाँ, tell me, Ram. थोड़ा जोर से बोलिए, Ram, please.
yeah, so I didn't understand how is it for the lone pair.
The lone pair electrons.
Yeah,
Okay, so you see this oxygen atom.
okay.
Okay, so it has this non-bonded electron. This is an electron, right? This one dot.
Okay.
It is not bonded to anything, right? Correct?
Yes, yeah.
ठीक है, ये दूसरा हो गया, ये तीसरा हो गया, ये चौथा हो गया. आगे बात समझ में?
अच्छा, okay. यहाँ, yes.
यहाँ पे कितने होंगे नॉन बॉन्डेड इलेक्ट्रॉन?
1.
नहीं,
1.
2 होंगे. 1 पेयर है
Oh,
यानी 2 होंगे. हाँ, इलेक्ट्रॉन्स. Okay.
Okay.
Similarly here, how many?
Pair?
No, electrons.
6.
6, yeah. The non-bonded electrons we have to look at, okay? Not the pairs. So calculate for the second one. And send the answer on chat only. We are only यहीं पे भेज दीजिए आप please. Okay, पर ठीक है. And what about the 3? What about the third one? Yeah, correct. So yes, Ram. Calculate for the second one also. Yes, very good. Okay, so the formal charge here will be equal to. Abdullah, आपका आंसर नहीं आया. Okay, so this is for the element. Element कहाँ पे होता है? Periodic table में. तो ये दोनों चीज कहाँ पे देखेंगे आप? एटम में देखेंगे. एटम इन मॉलिक्यूल. ओके, तो टोटल वैलेंस इलेक्ट्रॉन ऑफ किसका? ऑक्सीजन का. ऑक्सीजन पीरियोडिक टेबल में कितना वैलेंस इलेक्ट्रॉन होता है उसका? 6 होता है. नाउ द नंबर ऑफ नॉन बॉन्डेड इलेक्ट्रॉन्स, दैट मींस द लोन पेयर इलेक्ट्रॉन्स, नॉट द पेयर्स बट द लोन इलेक्ट्रॉन्स दैट वी आर हैविंग, that is equal to 2, so -2, and the number of bond that has is equal to 3. So you can see that this is 6 minus 5, which is equal to, you can say, +1, because it is charged, so I am writing the sign also. For the third case, the formal charge is equal to total valence electron minus the lone pair electrons, the lone electrons minus the bonds. Again, the total valence electron of oxygen element is equal to 6 minus the number of lone electrons that it has is equal to 6, and the number of bond it has is equal to 1. So you can see that this is equal to -1. Okay. Now let's do for one more. I think you have to draw the lowest dot structure for this and then calculate the formal charge and all. So please send the answer to me on WhatsApp, okay? Once you're done with this.
Sir?
Join us now. आवाज नहीं
जी?
आवाज नहीं आ रही है.
Sir, I'm saying can I join after some time?
Scroll up.
Hello?
Write in chat. Write in chat. Can't hear you properly. Okay, Fat, no problem. Okay, fine. आयरन CO3 टू नेगेटिव का हुआ क्या?
हाँ मैं कर रही हूँ.
अच्छा.
So
Yes,
so
sir.
कार्बन का भी फॉर्मल चार्ज बन गया है.
कार्बन का फॉर्मल चार्ज ना? हाँ. Fine for all the atoms.
Sir, I'm not sure कि ये सही है.
नहीं, स्टेप फॉलो करना है बस आपको, ठीक है। सही हुए तो खुद ब खुद हो जाएगा। आपका स्ट्रक्चर बिल्कुल सही है। अब देखते हैं आपके पास ऑक्सीजन। अब हम ये कैसे पता करें वन ऑक्सीजन कौन सा, दूसरा कौन सा, तीसरा कौन सा है? सो व्हाट आई एम गेसिंग इज,
Sir, आप लेफ्ट से जाओ.
जी what I'm expecting is, I think this is 1, this is 2, and this is sorry, this is
No, no,
3,
no, no.
this is
Yeah.
2, है ना?
Yeah.
ठीक है। And this is the fourth one, that is carbon। ठीक है, पहले का देखते हैं। नंबर 1, Fc is equal to total valence electron minus L minus bonds। तो आपके पास वैलेंस इलेक्ट्रॉन तो ऑक्सीजन में हमेशा 6 रहेगा एलिमेंट, क्योंकि माइनस नंबर ऑफ बॉन्ड पेयर्स, यहाँ पे आपके पास 1 2 3 4 5 6 होने चाहिए। So you will have 6 and number of bond is equal to 1, that will be giving you -1। Moving to 3 भी सेम किया होगा आपने, राइट? I mean there should be no change here। 6 minus 6 minus 1, yeah, 6 minus 1 -1। सेकंड का अगर देखें फॉर्मल चार्ज, then it will be 6 minus number of lone pairs कितने हैं, इलेक्ट्रॉन्स, नॉन बॉन्डिंग इलेक्ट्रॉन्स कितने हैं, नॉन बॉन्डेड इलेक्ट्रॉन्स कितने हैं इरम?
4.
ठीक है, 4 minus 2, है ना? कितना हो जाएगा ये? 0। आई थिंक यू आर आस्किंग योरसेल्फ क्या किया मैंने। ओके, सो फॉर कार्बन दैट इज करेक्ट। टोटल वैलेंस इलेक्ट्रॉन इज 4, देयर इज नो नॉन बॉन्डेड इलेक्ट्रॉन्स एंड 4 is the number of bond, this will give you 0। okay, you got what, where you gone wrong? Yes Iram?
Yes. हाँ.
Now see, there are a few lowest dot structure जिसका ना, if you don't know the skeleton then you will not be able to make the skeleton। ठीक है, for example I'm giving you a few। HCOOH, या फिर आपके पास यहाँ पे HCOH ही देंगे आप, H3PO3, HPO4, H3PO4, H2SO4। ठीक है, so these are some of the examples जहाँ पे आपको skeleton पता होना चाहिए क्या है। Now here if you see there is something common here, as you can see we have hydrogen and oxygen and there is a non-metal। दिख रहा है आपको? yes or no Iram? सब में हाइड्रोजन और ऑक्सीजन है, बस नॉन मेटल चेंज होता है, राइट? हियर वी हैव कार्बन, हियर वी हैव फास्फोरस, हियर वी हैव फास्फोरस एंड हियर वी हैव सल्फर। सही है इरम? yes or no please tell me।
Yes.
ठीक है, अब इन केसेस में कैसे आप बनाइएगा, ऑब्वियसली यू कैन सी दैट, आपको दिख रहा होगा कि यहाँ पे हम सेंट्रल एटम तो हम बता देंगे। यहाँ पे सेंट्रल एटम किसको लीजिएगा आप बताइए जरा, व्हिच वन विल यू टेक एज सेंट्रल एटम?
Carbon.
कार्बन। यहाँ पे किसको लीजिएगा?
Phosphorus.
फास्फोरस। यहाँ पे किसको लीजिएगा?
Phosphorus.
फास्फोरस। और यहाँ पे
Sulfur.
सल्फर। बहुत सही, ठीक है। तो इसमें आपको दिक्कत नहीं होगी जब आपको सेंट्रल एटम लेना होगा, लेकिन उसके बाद जब स्केलेटन बनाना है देन यू विल बी वरीड, लाइक कार्बन के साथ हम क्या करें भाई, यहाँ पे हाइड्रोजन, ऐसे ऑक्सीजन, फिर ऐसे ऑक्सीजन, फिर ऐसे हाइड्रोजन, ऐसे बना दे क्या? सो ऐसे आपको नहीं बनाना, ओके? यू डोंट हैव टू मेक इट लाइक दिस। यहाँ पे यू डोंट हैव एनी चॉइस, यू हैव टू ऑलवेज, एक चीज कॉमन रहेगा सब में, दैट विल बी कार्बन, यानी जो भी नॉन मेटल, जो भी आपके पास सेंट्रल एटम है, इट विल हैव अ डबल बॉन्ड विद ऑक्सीजन। ठीक है, सबसे पहले आप क्या कीजिए, कार्बन का डबल बॉन्ड ऑक्सीजन, यहाँ पे फास्फोरस का डबल बॉन्ड ऑक्सीजन, एक डबल बॉन्ड तो रहेगा ही रहेगा सब। यहाँ पे भी फास्फोरस का डबल बॉन्ड ऑक्सीजन, यहाँ पे सल्फर का डबल बॉन्ड ऑक्सीजन। सही है? ये सुनो प्लीज, चल भी गाइस, गाइस के अब तो बस आप ही बचे हैं जी।
Yes, see.
ठीक है, अच्छा। अब आप क्या कीजिए, अब आप यहाँ पे डालिए, उसके बाद बचा हुआ ऑक्सीजन एक, ठीक है, अब बताइए यहाँ पे हाइड्रोजन बच रहा है, हाउ मेनी हाइड्रोजन आर देयर एरम,
हाँ 1.
कितना है? ठीक है, आपके पास एक ऑक्सीजन बचा था, आप पहले ऑक्सीजन भी क्लियर कीजिएगा। तो आपको एक ऑक्सीजन बचा था, आपने ऑक्सीजन पे डाल दिया, एक हाइड्रोजन आप जोड़िएगा ऑक्सीजन के साथ, यानी कि इट विल बी लाइक दिस, और दूसरा हाइड्रोजन कार्बन के साथ। ठीक है, अब आपको समझ में आएगा, धीरे धीरे
Okay.
आएगा। ठीक है, गड़बड़ाइए नहीं, गड़बड़ाइएगा नहीं। यहाँ पे देखते हैं फॉस्फोरस वाले के साथ। ठीक है, वी आर मेकिंग फॉर H3PO4। ठीक है, नाउ यू हैव गॉन 1 ऑक्सीजन। अब बताइए कितने ऑक्सीजन बचे हैं, और 2 ऑक्सीजन बचा हुआ है, सही है,
Yes, 2 oxygen.
2 ऑक्सीजन डाल दीजिए आप, सिंगल बॉन्ड। ठीक है,
Okay.
ठीक है, अब बताइए हाइड्रोजन कितने बचे हुए हैं,
3.
3। तो 2 हाइड्रोजन किसके साथ चले जाएंगे, ऑक्सीजन के साथ, और एक हाइड्रोजन किसके पास लग जाएगा, फॉस्फोरस के पास। बात समझ में आ गई?
Okay. Understood.
ठीक है, अब इसमें बताइए H3PO4 में क्या करेंगे, पी डबल बॉन्ड O तो है हमारे पास, यहाँ पे पी डबल बॉन्ड O, राइट।
Yeah. 3 oxygens.
एक सेकंड, ऑक्सीजन ऑक्सीजन ऑक्सीजन, और बताइए यहाँ पे हाइड्रोजन कहाँ लगेगा, अब
Oxygen के लिए.
तीनों ऑक्सीजन के पास एक एक हाइड्रोजन लगा देंगे हम। ठीक है,
Yeah.
नाउ व्हाट अबाउट H2SO4, H2SO4 में आपके पास सल्फर है, सल्फर
3
डबल बॉन्ड। अब
oxygens
बताइए कितना हाइड्रोजन, 3 ऑक्सीजन। ठीक है, अब
and 2 hydrogens.
ठीक है, अब जब हाइड्रोजन दे दिया आपने, ये ऑक्सीजन के पास कुछ नहीं मिला, इसको ना हाइड्रोजन मिला, तो यहाँ पे इसको डबल बॉन्ड मिल जाएगा। ठीक है,
Yes.
ठीक है, तो दिस इज वन ऑफ द लिमिटेशन ऑफ द ऑक्टेट रूल। यहाँ पे देखिए, अगर आप यहाँ पे सल्फर के पास कितने इलेक्ट्रॉन्स हो जाएंगे, 1 2 3 4 5 एंड 6 बॉन्ड, 6 बॉन्ड्स मींस 12 इलेक्ट्रॉन्स, राइट। सो ऑब्वियसली इसके पास 8 से ज्यादा इलेक्ट्रॉन है, तो हियर द ऑक्टेट
Sir,
रूल इज नॉट वैलिड। हाँ बताइए।
अगर ऑक्सीजन के पास हाइड्रोजन नहीं आया तो वो डबल बॉन्ड होगा.
हाँ, ऑक्सीजन के पास अगर डबल हाइड्रोजन नहीं है तो डबल बॉन्ड, देखिए आएगा, यहाँ पे नहीं आया आपके पास। जी फिर बोल रही हैं,
नहीं मैंने.
प्लीज राइट दिस डाउन, नहीं लिखा है आपने तो, एंड मेक वन स्ट्रक्चर, और आप उनको चैट में भेजिए व्हाट्सएप में, H3PO2। And Iram, what happened to Aisha? Aisha बहुत दिन से नहीं आ रही है classes.
सर आपको पता है उसने लीव कर दिया.
नहीं पता था. अच्छा. Yeah, that is correct. Okay. Now write the topic limitations of lowest octet rule. अच्छा, ये स्केलेटन के लिए हमने बता दिया है, बाकी आप इसके बाद हम अभी पढ़ाएंगे, आपको स्क्रीनशॉट भेजेंगे, आप यहाँ पे स्क्रीनशॉट ले सकते हैं.
सॉरी सर आपकी आवाज़ नहीं आई.
नहीं, I'm talking to Fahad. You can take the screenshot, but you have to like revisit the lecture. आपको देखना पड़ सकता है because there's not much in the screenshots here. I'll wait for like 5 seconds. Fahad, tell me.
सर टॉपिक क्या है ये?
I was talking how to make the structure when you have this type of molecules.
सर आप रिकॉर्डिंग कब दे सकते हैं, जितना जल्दी पॉसिबल?
रिकॉर्डिंग कल अपलोड होगी.
कल? आज नहीं सकता?
कल शाम हम बोल देंगे, अगर हो पाएगा तो वो अपलोड कर देंगे, लेकिन जनरली वो देखिए लोग ऑफ हो जाता है ना फिर टाइम. जैसे अभी आपको पढ़ाई खत्म करेंगे, लोगों का टाइम खत्म हो जाएगा तो वो जाएंगे घर भी अपने, है ना. देन दे विल
तो
कम.
आप पर्सन भी नहीं दे सकते ऐसे?
क्या, कहाँ से?
मतलब व्हाट्सएप पे आप भेज दीजिए. आपके पास नहीं है क्या रिकॉर्डिंग?
नहीं, हम ये क्लाउड पे होता है ना रिकॉर्डिंग, लाइक मेरे सिस्टम पे नहीं होगा ना, आप सोचिए मेरे सिस्टम पे नहीं
अच्छा
होगा.
अच्छा.
ठीक है, तो इट इज ऑन जस्ट लाइक जूम अकाउंट जो है लर्निवियो का, उसके क्लाउड में रहता है. ओके,
ठीक.
तो वहाँ पे जितने भी लेक्चर्स आप अटेंड करते हैं फिजिक्स और मैथ्स, सब वहीं का रहता है, नॉट इन एनीवन्स सिस्टम. हम बोल देंगे लेकिन, ठीक है, अगर वो के करीब, ठीक है, और अगर अपलोड कर देंगे तो हम बोलेंगे कि अपलोड करके आपको भेजने के लिए लिंक. ठीक है,
ठीक.
ओके ना.
जी.
स्टार्टिंग में यहाँ पे वी हैव डन फॉर्मल चार्जेस, शायद आप थे उस टाइम तक, राइट?
जी मैं था.
हाँ, तो बस उसके बाद अभी लिमिटेशंस ऑफ right here. Number 1, not applicable on hydrogens as it can. Okay, hydrogens क्या होता है? Sorry, not applicable on hydrogen as it can accommodate only 2 electrons. ना, उससे ज्यादा ये accommodate कर ही नहीं सकता. Right, next. Does not explain stability of electron deficient compounds. Okay, for example, we have lithium chloride. So lithium, it has, like, it's not like this obviously, lithium and then chlorine, right? So lithium chloride, it cannot explain because the lithium, it has how many electrons? It has only 2 electrons. Okay, but it is against this molecule has been found, and if the molecule has been found, that means it is a stable molecule. But Lewis octet rule cannot explain the stability of this type of molecule. Then we have, for example, hydrogen, beryllium, and then hydrogen. So again, beryllium, it has only 4 electrons. Hydrogen का तो हमने पहले ही explain कर दिया that it can Lewis octet rule को follow नहीं करता है. But beryllium also here you can see that it is only having 4 electrons in this particular phase, in this particular molecule. Similarly, आपके पास you will have BeF2. Fluorine, fluorine. Then we have BF3. So obviously, fluorines are having some lone pair electrons, but we are more concerned about the beryllium, and here we are more concerned about the boron atom. So boron atom, as you can see, it has only 6 electrons in the valence shell right now. Okay, so it cannot explain all of these things. If you want to write some more compounds, you can write we have written BH2, okay. So you can write boron hydride, that is BH3. Then you can write what else? BeCl2. Okay, these are some other compounds that it does not explain the stability of. In both the cases, the boron is having 6 electrons, the beryllium is having 4 electrons in the valence shell. Now write the third point. Does not explain stability of electron-rich compounds. क्या बाहर गए हुए थे क्या फहद?
जी. यस.
घूमने?
नहीं, नमाज पढ़ाई.
नमाज पढ़ने गए थे?
जी.
ओह अच्छा, टाइमिंग थोड़ा सा ये हो गया है. ओके, राइट. नेक्स्ट, molecules that have more than 8 electrons around central atom are called electron-rich compounds. Okay, next slide. The central atom in such compounds belongs to the third period of the periodic table. Okay, the third period or below. Okay, या फिर उसके नीचे, third period and onward, 4th, 5th. As you know that they have the D subcell, right? And when they have D subcell, they can expand their object. For example, you have TF5. Okay, you will add the lone pairs for fluorine. Similarly, you can have SF6. As you can see, all of these are having more than 8 electrons. Iodine can have IF7. सब हो गया 3. Okay, so this has how many electrons? 10 electrons. This has 12 electrons. This has 14 electrons. Similarly, अभी हमने एक स्ट्रक्चर देखा है सल्फर का H2SO4 का, in which the structure is something like this: double bond O, OH, OH. So here the sulfur is having again 12 electrons. All right, next. These compounds are also called hypervalent compounds. And the fourth point, does not explain the stability of odd electron species. Okay, for example, NO. So if you see the total valence electron also, you will see nitrogen has how many valence electron? 5, right? And oxygen has how much? 6. 6 plus 5 is 11, है ना? तो उस हिसाब से भी यहाँ पे देखिएगा. So for example, the nitrogen will have double bond with oxygen. Oxygen will have these electrons like this. Nitrogen is going to have 1, 2, and then the third electron here. यहाँ पे देखिएगा नाइट्रोजन का ऑक्टेट जो है वो कंप्लीट है, and it is having this one electron, जो odd electron species है. Okay, similarly you will also have NO2, nitrogen dioxide. Here again, nitrogen with a double bond oxygen, and it is having the pairs of electron like this. Then you have a single bond with oxygen, and now if you see here, this nitrogen is going to have 1 electron. Okay, and this oxygen is going to have 1, 2, 3, 4, 5, and 6 electrons. आपको अगर याद हो NO2 नेगेटिव था, तब यहाँ पे नाइट्रोजन के पास 2 इलेक्ट्रॉन थे, ठीक है, but nitrogen is going to have only 1 electron. If you are going to draw it, then you will see that it's going to have only 1 electron here. After completing the octets of, after making the oxygen and this oxygen happy, because we always make the side surrounding atoms happy first, then we add electrons if anything is remaining onto this nitrogen, like that is the central atom. ठीक है. Done. Hiram and Fahad.
Yes.
Understood. What about you, Hiram? Done.
Yes.
Okay. Right, next topic, that is bonding theories. Okay, now we are going to learn 2 different bonding theories. One is known as the valence bond theory. And the other one is known as molecular orbital theory. We can abbreviate this as VBT, and we can abbreviate this as MOT. Okay. So first of all, we'll start with the valence bond theory, and then we will move on to the molecular orbital theory. But again, this complete valence bond theory itself is going to take a lot of time. So Let us start with a few introductory remarks about valence bond theory, and then we can start moving further on and diving deep into the valence bond theory. Okay? So, right, first of all, the valence bond theory. The valence bond theory. So, the valence bond theory, it says that we have seen orbitals, right? We have seen orbitals. And valence bond theory says that the covalent bond, it is formed by the overlapping of two half-filled atomic orbitals. Okay, when we have half-filled atomic orbitals and when they overlap, that means one orbital containing one electron, the other orbital containing one electron. That means you have atom A, it has some orbital like this, it has only one electron with up spin. There will be B with some opposite spin. Okay, and when they will combine with each other, they are going to form a bond like this. Okay, they're going to form a bond like this. Okay, so this is the main idea behind your valence bond theory. So please write covalent bond is formed. Covalent bond is formed by just a second, let me plug in my charger. Is formed by overlapping of two half-filled atomic orbitals. Atomic orbitals I will be referring as AO many of the times. Okay, atomic orbitals of their valence shell. Okay, of their valence shell. Now, next point is, like, you imagine them as holding hands. Okay, so for example, if two people are holding hands and they are just holding their hand with their fingers. Okay, so you have the finger like this, somewhere like this, and they are just touching each other like this. So you can see that this bond here, if they are just touching each other very lightly, then it is not going to be very strong. But for example, two people are holding themselves arm to arm. So one person is holding one arm here, the other person is holding the other person's arms here. Arm to arm कैसे पढ़ा जाता है आपने देखा है?
Yes, शायद.
Yeah. Okay, so something like this. Okay, so obviously this hold is going to be like very effective. So same type of concept is there in valence bond theory, that if you have a greater extent of overlapping, then the two atomic orbitals will form stronger bonds. Okay, so please write greater the extent of overlapping, greater the extent of overlapping between two atomic orbitals, stronger is the bond form. Stronger is the bond form. Next thing is that for effective overlapping, there must be proper orientation. ओरिएंटेशन का मतलब जो डायरेक्शन होता है आपका ना, डायरेक्शन, प्रॉपर ओरिएंटेशन बिटवीन the two atomic orbitals. देखिए आप लोगों ने SN ऑफिशियल में
Done, sir.
डन, ठीक है। अब have you guys learned about waves? Anything about waves? वेव्स के पास आपको, ठीक है, ज्यादा कुछ नहीं, आपको ये पता है कि पॉजिटिव फेज होता है, नेगेटिव फेज होता है वेव का एम्पलीट्यूड के अकॉर्डिंग। यस और नो प्लीज टेल मी।
यस
एरम, आपको आइडिया है इसका?
नहीं।
अच्छा, नहीं, ठीक है। तो आपने अगर वेव देखा हो तो वेव इज समथिंग लाइक दिस, राइट? So this is the positive part of the amplitude, negative part. This is the positive phase and this is the negative phase. ठीक है एरम? ओके,
Okay. Yeah.
ठीक है। अच्छा, अब खुद सोचिए, अगर हमने यहाँ पे like just imagine about the sound wave that we have, okay? So अगर sound wave है आपके पास और हमने यहाँ पे एक और sound wave लाया कुछ इस तरह से, ठीक है? तो यहाँ पे आप एक काम कर लीजिए, बिल्कुल सेम ही साउंड वेव हम ले आते हैं यहाँ पे ना, ठीक है? अब जो इसका रिजल्ट होगा, इन दोनों का अगर हम ऐड करेंगे, ऑब्वियसली जो एम्पलीट्यूड है दैट विल इंक्रीज। यस और नो प्लीज टेल मी।
Yes.
ठीक है, पॉजिटिव एंड नेगेटिव। बट इफ द रिवर्स इज देयर, समथिंग लाइक दिस, एंड यहाँ पे हमारे पास कुछ उल्टा इस तरह से, ठीक है? हियर वी हैव पॉजिटिव, हियर वी हैव नेगेटिव, हियर वी हैव नेगेटिव, हियर वी हैव पॉजिटिव। इसका जो रिजल्टेंट होगा वो क्या होगा? नथिंग। यस और नो? सही है। So the
Yeah.
noise cancellation things that work, they work in the same principle that they generate noise of the opposite amplitude. Okay, so generally the बहुत अच्छे noise cancellation आपके पास, you may have earphones or you may have systems which are noise cancelling. Those have the same. This is known as constructive interference. This is known as destructive interference. Okay, so for destructive interference, you should have. This is my sound wave, just the opposite phases we are going to give, and it is going to cancel the noises. Okay. Now, once you have learned this, you should know that all the atomic orbitals are also what? All of these atomic orbitals are also waves, and they have positive and negative signs. They have positive and negative signs, and these signs also refer to what the phases in a wave. Okay, जब आपके पास ये देखते कुछ इस तरह से ना, when you look at the p orbital like this, and it has a positive phase and it has a negative phase. These are not charges, these are just phases because it is a wave. Okay, it is a wave. This side it represents the positive phase and this side represents the negative phase. Now, similarly, here you will write types of overlapping. Okay, so because overlapping can happen, ये देखिए same चीज है, ये overlapping ही हो रहा है यहाँ पे किसका? Waves का. Similar overlapping you are going to have. So please write types of overlapping. Types of overlapping. Okay, types of overlapping. Now the first type of overlapping is known as positive overlap. You have three types. There are positive overlap, there is negative overlap, and there is also known as something which is zero overlap. Something which is known as zero overlap. Right, the number 1 point, positive overlapping. In this case, this is the simplest one, overlapping. Of atomic orbitals with same sign of psi. Psi क्या है आपका? जो फेज बताता है आपको, ठीक है? Positive overlapping results in attractive forces. This results in attractive forces. For example, आप हम कुछ example दे देते हैं positive overlapping का. For example, you have the s orbital with a positive phase, and you have a p orbital with this positive phase, and here we have a negative phase, and both of these are interacting in this order. Okay, so they are interacting like this. So if I am going to overlap them, then it is going to overlap like something like this. Okay, so here we have positive. So positive sides are overlapping, so there will be attractive forces between them. Similarly, you can have positive and other positive s orbital. In this case, you will have overlapping like this. Both of these are positive phases. So these all will lead to attractive forces. Okay. Similarly, you can also have negative as well as negative. The idea is not that positive should only overlap with positive. Negative, it should be same. Okay, I'm not saying it should be positive only. It should be same. So this is also a case of positive overlap. Please remember that. Okay, this is also a case of positive overlap. The criteria is that the sign of psi should be same. Similarly, you can have something like this. Negative, negative, positive, and positive. So, and they are interacting in this order. So when they will come close together, this type of overlapping will take this negative, negative, and here we have positive and positive, right? This is also, all of these are examples of positive overlap, which results in attractive forces. Done everyone? Yes or no? Please tell me. अच्छा, और हम एग्जांपल दे देते हैं आपको कुछ. पॉजिटिव, नेगेटिव, पॉजिटिव, नेगेटिव. अब ये दोनों साथ आएंगे तो देखिए, पॉजिटिव वाला किसके साथ ओवरलैप करेगा? पॉजिटिव के साथ. नेगेटिव वाला नेगेटिव के साथ. सो दिस इज आल्सो अ केस ऑफ व्हाट? दिस इज आल्सो अ केस ऑफ पॉजिटिव ओवरलैप. ठीक है. डन गाइस? yes or no? Please tell me. Iram and Fahad, please tell me. देखिए, ठीक है. Next देखिए, negative overlapping. Am I giving number? Yeah, I'm giving numbers. As you may have guessed it, that is the overlapping between atomic orbitals with different signs, different sign of psi. This results in repulsive forces. For example, we have positive, negative. When they are going to overlap with each other, so this area will be vacant now. ठीक है? ये क्या हो जाएगा? खाली हो जाएगा ये area. Because positive phase is overlapping with negative phase. I'm writing here red type इस तरह से. This will become vacant. There will be no electron here. ठीक है? There will be no electron here. It's positive. This is negative. So I think you get an idea like what kind of orbitals can show this type of thing. positive, negative. Here we have negative, let us suppose. Oops. And then we are going to have a circle like this, and then red things. That means there is no electron here. This was negative, this was positive, and this was negative. Similarly, you can also have okay. चलिए आज के लिए इतना ही. Okay. Tomorrow, that means on Thursday, we'll learn a bit more about this valence bond theory, and then we'll move forward. एक और तरीके का overlapping होता है, that is known as zero overlapping. एक और एग्जांपल आपको दे देते हैं zero overlapping का, ठीक है. So zero overlapping happens when you are overlapping with some parts of positive and some part of negative. For example, if you have something like this, this is positive. ये बनता ही नहीं है सही. Positive, negative, ठीक है. And then I have s orbital like this. And यहाँ पे आपके पास क्या होगा? You will have the s orbital like this. तो ये आपको दिख रहा होगा यहाँ पे. This is my positive overlap because this is positive and this is positive. But उसके नीचे जो आपके पास overlapping हो रही है, that is with the negative phase. So this is not good. So this is known as आधा positive आधा negative. आपको क्या मिल जाएगा? Zero. Okay, so this is zero overlapping.